Do you know something absolutely crazy? Every single day, millions of videos are uploaded to YouTube. Think about that for a second. Millions of new videos every single day. Now imagine the amount of storage, processing power, networking, and infrastructure required to store and deliver all the data to billions of people around the world. Some estimates put YouTube's total video storage in the 10 to 15 exabytes range. Let me show you how insanely large 1 exabyte actually is. We normally talk about storage using megabytes and gigabytes. A few gigabytes can hold hundreds of photos, a movie, or even a small game. Then we move to terabytes. Roughly 1 terabyte is 1024 gigabytes. That's already enough storage for a huge personal collection of photos, videos, games, and documents. Now go to one level higher. Petabyte. 1 petabyte is 1024 terabytes. That's roughly the storage capacity of 1001 terabyte drives. At this scale, we are no longer talking about personal computers. We are talking about data centers infrastructure. And then we reach the monster, exabyte. 1 exabyte is 1024 petabytes. Oof, that's an absolutely massive amount of data. And YouTube has to deal with data at this kind of scale. But here is the real question. How does YouTube actually handle all of this? How does it store multiple video qualities? How does it process millions of uploads? How can billions of people stream videos simultaneously? And what happens if a data center goes down? Let's break it down. First, YouTube doesn't simply take your original video file and keep delivering that exact file to everyone. When you upload a video, YouTube processes it. The video is transcoded and compressed into formats and resolutions suitable for streaming. So your 4K video isn't necessarily delivered as one giant 4K file. Instead, YouTube creates different versions and streaming representations of that video. For example, 144 pixel, 360 pixel, 720 pixel, 1080 pixel, 2K, 4K and 8K. And depending on the video and supported formats, there can be additional encodings as well. This is extremely important because your phone doesn't need a 4K stream when you are watching on a slow internet connection. And YouTube doesn't want to waste bandwidth sending 4K video to a device that can only display 720 pixels. Now imagine you upload a 10GB 4K video. YouTube can break that video into many small segments and encode these segments into multiple resolutions and formats. YouTube uses highly efficient video codecs such as H.264, VP9 and AV1. These codecs dramatically reduce the amount of data required to stream video while maintaining good visual quality. So the final stored data is not simply original 10GB file multiplied by every resolution. The actual storage depends on the video's duration, bitrate, resolution, codec, frame rate, audio, and other encoding parameters. The estimated compression results around 1.5 GB to 2 GB of all formats and resolutions, which is almost 80% reduced than original raw file size. Now comes another huge problem. What happens if the storage server containing your video is crashed? Does your video suddenly disappear? No. Large-scale cloud systems use redundancy and distributed storage techniques. Data can be stored with multiple copies or using erasure coding across different storage infrastructure. So if one piece of infrastructure fails, the system can recover the data from other available pieces. This is one of the fundamental ideas behind Google's enormous distributed infrastructure. But there is another problem. Imagine a video suddenly becomes viral. Millions of people are trying to watch the same video at the same time. If every viewer had to retrieve every byte directly from distant storage system, that would create an enormous amount of traffic. So YouTube uses caching and content delivery infrastructure to bring frequently requested content closer to users. Popular content can be served from infrastructure geographically closer to the viewer. That's why you can start watching a video from thousands of miles away and still get a smooth stream. But how does YouTube keep the video playing without constantly downloading everything at once? Here is another clever trick. YouTube video is delivered progressively in small segments. The player can request upcoming segments before you actually reach them. So while you are watching one part, the next parts can already be downloaded in the background. That's why the video can continue playing smoothly even when your network speed fluctuates. And here is something even more interesting. YouTube doesn't necessarily send you a highest quality versions all the time. It continuously adapts the stream based on things like your network speed, device capabilities, screen resolution, and current playback conditions. Slow connection, you might get a lower quality stream. Fast connection and a capable device, you may get 4K. This is called adaptive streaming. The goal is simple, maximum quality without constantly buffering. Now you are probably thinking, okay, but video uploads keep increasing every day. Won't YouTube actually run out of storage? This is where Google's infrastructure becomes crazy. YouTube is part of Google, and Google operates a massive global infrastructure consisting of data centers, network systems, system hardware, computing infrastructure, and specialized facilities. As demand grows, infrastructure can be expanded. More storage, more servers, more network capacity, more data center capacity. So YouTube isn't relying on one giant hard drive somewhere. It's a massively distributed system spread across enormous infrastructure. That's the real secret. And finally, how long does YouTube keep your video? You might think forever. Well, not necessarily. YouTube doesn't promise that every video will remain available forever. Videos can be removed based on things like copyright violations, community guideline violations, or other policy and legal requirements. And account inactivity can also matter under Google's applicable policies. But when you step back and look at the whole picture, it's absolutely mind-blowing. You upload one video from your phone, and behind that simple upload button, there is an enormous chain of technology working together. Your video gets uploaded, processed, transcoded, compressed, stored, distributed, cached, and streamed to viewers across the world. All while billions of people are simultaneously uploading, searching, watching, liking, commenting, and sharing content. And this is possible because of something much bigger than just YouTube, which is Google's global infrastructure. Massive data centers, high capacity networks, global fiber connections, distributed storage, content delivery infrastructure, and enormous computing power. That's the engineering behind simple YouTube player you see on the screen. Personally, I have been using YouTube since I was around 14. I use it for learning, technology, movies, trailers, music, and entertainment. But after understanding what happens behind that simple play button, you realize YouTube isn't just a website. It's one of the largest distributed computing and video delivery systems humans have ever built. So what do you mainly use YouTube for? Learning, entertainment, music, or something else? Let me know in the comments.